Unless you did not know, you are at the Let's Take It Easy session. My name is Adi, and this is going to be a coding. I just wanted to play. Hold on, don't go too fast. That's not what I want you to do. So, hold on. I had this dial down when I was at home. So, present full screen. Okay, it was on autoplay. Sorry about that. So, let's go back. And we looked at the binary search. So, usually, whenever you say, I want to start a computer science like PASS, or I want to go for FANG, they tell you, okay, go to a lead code testing algorithm or anything like that. And this is how they will go and present you a problem. We already went through that, but one of the things is, one of the keywords here are these things that I highlighted in pink, and we're going to get back to that. And we saw together how we solve this by just going like dividing, comparing, and then eliminating, and keep on doing the same thing. So everybody here knows that we're going to be using some type of loops, look at some condition and everything like that. Because I feel like the coding part is the simplest part once you got the syntax right. But understanding what is being asked from you, having that deep understanding of it, and then know when to apply that knowledge. One of the things that we were able to do with the binary search that some of you were able to see, we only were able to do that because the numbers were in ascending order. Because we can assume that if I get to this number, anything on the left is less, anything on the right is more. But if you do as unsorted, that would be another way of attacking the problem. So those little words, are they sorted? And then here they're asking you search. So the moment they say search, you know that you have to deal with a search algorithm. So those little things start learning that vocabulary, how the academia is presenting a problem. But then rephrase that problem, give it a mental model that works for you. And if you are a teacher, draw a mental model that works for your student. All right? So this was binary search, and for the sake of time, I'll show you the code, both of the code running in real time before the end. So there's another one, and I'm going to ask you the same question. This is called the move zeros algorithm. And look at the language that is being utilized here. Given an integer, array is nums. So you're assuming that there's an array called nums, and that's an array of integers. How about I have an array of integers called nums? But okay, for me coming from a third language, this is very convoluted way of saying the same thing. Given an integer array nums, move all zeros to the end of it while maintaining the relative order of the non-zero elements. How many people, just looking at this, know what it's asking from you? 2, 3, 4. How many people have no clue what the problem is about? How many? How many do not care? So that is, imagine if you were just to come and you're making your first interview at the Google, at the Facebook, and then this is what they put in front of you. Of course, I will advise you to train before. I will advise you to do your due diligence. But if you have never seen this type of problem before, you are smart. You know how to solve this. But then you're going to start ventilating, stressing out. I was showing it to a few people yesterday, and their reactions was just priceless. Now, there's another way that they presented. I took one from LeetCode, one from Geeks for Geeks, and to just tell you that the problem is in the vocabulary and how we present concepts. If we present it in an approachable way, in a plain English, God damn it, just do it in plain English, then all of us will be able to at least have a point of reference and start solving for this. Okay, so don't even worry about this one. That gives you this. I had no idea. I stayed almost for an hour and a half just trying to understand what it was when I first tackled this problem. Now, let's go in plain English. We have a finite number of rooms, okay? And we have the secret service in town. Each of them with their secret service ID for the room they occupy. So the Secret Service ID number 1 is there, the guy number 9 is there, 8, and so forth and so on. But there are some empty rooms, and that's the zeros right here. Now the chief of the Secret Service comes and say, hey, I need my guys and girls to be together. They need to be next to each other. I cannot have them separate because, like, you know, I want them to be able to quickly react. So now we know that we have a finite number of rooms. We cannot create more rooms. We need to move them. And then usually you will see that they will say either move them to the left or move them to the right. Any ideas now? Now, take your hat and now you're the hotel manager who's like, oh damn, the Secret Service, man, they always have like so many freaking requests, but the money is good. So let's deal with it. How would you deal with it? Let's make it a human problem. How would we deal with something like this? Any ideas? All right, let's say like the red arrow is the manager, and then the blue arrow is the kid who's just like, you know, doing the summer job and just like, what did I get into in the first place? All right? So one way to solve this is they're going to go, so we're trying to move them to the left this time, okay? So if we're trying to move them to the left, we're starting from the right. He's going to check the room. The manager is checking the room. And he's seeing that the room, oh, okay, I think I went a little far. There you go. He's checking, and he sees that this room is empty, but that's the last room. He's not going to be able to do anything about it. Now, he's the one who moved, but the kid did not move. He's staying in place because he doesn't have any job to do yet. Now he sees one agent at the next room, and he says, hey, I have an agent here. Do you have an empty room? And he says, yes. He says, okay, agent, can you move to the room where my worker is? Then, you know, he moves there, and then, you know, since like now he has a room that is filled with an agent, at that moment, the kid moves. He only moves when he has a job done. Everybody's following me? Okay. Next, he comes, he sees an empty room, there's nothing to do here. The manager keeps going. He sees another agent, same process. He moves him or her, and then what the kid does, he moves down. Okay? So we're going to go faster now. You're going to see that like repeating this cycle up until all of the agents are moved. Okay? Now the manager knows he's at the end of the room. What is he going to do? He's going to start traveling back and say, okay, I can mark this one empty. 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 Now we have moved all of our zeros to the left, and then we have respected the order of the agent, however they were. So it's up to you. For me, that's how I was able to like kind of translate it into a language that made sense to me. I made it a human problem. I did not make it a computer problem, a computer science problem. I was like, if I was to do this, how I would go about it. Now, when you have something like that, at the end, what you will do, you translate that language into code. And I'm going to just walk you through the code real quick. Since now you have a point of reference, since now you have a mental model. So let's present this. Okay, so we have a function that moves zeros. And then we said that we had a manager and a worker. So the manager, we're going to call him the read index. You're going to hear like different terms, pointers and stuff like that. But the manager is going to be the read index. And then the worker is going to be the write index. Okay? Read and write, those two index. Everybody's following me so far? Good. Now, the read and the write index are going to start at the same position, which is at the end of the rooms. So you see, I'm assigning them the same value, which is basically taking like the length of the array minus 1. That's it. So if we had 7 rooms, they're both starting at position 6. Because of what? We go from 0 to x. Everybody's still following. I'm not saying anything new. I already talked about this 20 minutes ago. If you were not following, yeah, okay, you can just go like time out for 2 minutes. Don't go though, stay. So the read index is our manager. The write index is our worker. And they start at the same position. We got that? Now, we're going to go, you knew that we're going to have some type of loop. So while the read index, because the read index doesn't care. Every single time, every single iteration, it's going to keep on going like one less, one less, one less, until it gets to the end. So while we have a read index that is greater or equal to 0, then what is going to happen in this room is going to be executed every single iteration. Okay? So now, while we have that, if the array at the box read index is not equal to 0, now I'm not speaking any like foreign language to you. We saw it in the visualization. If it is not 0, you know, what does he do? He will tell to the write index to take whatever value was there and put it now in that new position. And then write index, the kid, at that time, and only at that time, he moves one slot down. That's why we have write index minus minus. That's the only time he moves or he changes positions. Okay? Now, if that's not the case, what's going to happen? And that's why I wanted to highlight this part. Read index keeps going to the next slot. So what you have here is one full iteration. They start at the top, which is like at the end of the array, at the same position. The manager, I'm not going to bother anybody anymore. The manager checks first and sees a 0 or whatever. There's nothing to do. That's the last one. So he moves, he sees somebody, and he says, we have somebody, can I move him up or not? And then he says, okay. Then he moves. The moment that he did his job, he will then move. That's the only time he moves. But the manager, he keeps going. All right? That's like the code in plain English right there. And that's one iteration. Now, this is going to go all the way till we get to the 0 spot. Then what's going to happen next? What's going to happen? Okay, we already talked about this. Now, the manager is going to start traveling back and checking all the room empty until he meets the worker. Okay? So for let I equal 0, but now I is less or equal to write index position. Not the whole array. If not, you're going to just mark everything 0 again. So that is the very nuance here. I is going to be as much as the position of where your worker is. Okay? So what he's going to do, he's just going to make sure that every single slot now is marked as a 0. That's the entire algorithm right there. If I started here, I would have lost probably 2 or 3/3. 3/3 would be everybody. So let's say, almost everybody. But now this, even though some of you are still squinting, you have a point of reference. You have an understanding. And now you're going to see a lot of other problems. There's a lot of other problems that you're going to see worded in a certain way. You're like, oh, okay, I might need one or multiple indexes or one or multiple pointers to solve this problem. So the last thing I'm going to do is, do you guys want to see the code running? At the end of the day, does this work? Yeah, you guys are going to hold me honest. Okay. You did not have to do that, but that's fine. So we talked about the binary search, and I had a video of it. So I'm going to play it real quick. And basically, can everybody read? Yeah. So the binary search that we did, we have a minimum of 0, the maximum of the length, the guess index, and the temp value. So if you find me afterwards, we can go line by line, and you can, but you saw the example. We did it live here. Does it work? So So here we have that, but now, here, I want to show you something real quick. These are prime numbers. There you go. These are like the first 60 prime numbers. And we know that prime numbers are like ordered. They go from like the smallest to the highest. And we're using the binary search to solve for this. And now I'm asking my function if like I can make it bigger for some of you guys. I'm asking it, find me in my prime, I'm passing like prime 60, which is the array, to my function, and say find the number 181. Okay? And then what you're going to see, right here, command minus, there you go. So the first iteration, it went and it did like, you know, we found 181 in array at index 41. But look, how many iterations? 60. And I go 1, 2, 3, 4, 5, 6 iterations to find 181. Okay? On the second one, when I asked it to find number 500, it went through everything and said value 500 was not found. But it took it like about 6 iterations again to see that it was not there. So that is very, very efficient. And last but not least, we have the binary, what is it called? The move 0. So I have it ready for you here, and I'll make it bigger, don't worry about it. So if you go to sources, okay, I have 2 of them. So here is our move 0, basically, that you just saw like in slide format. So if I do command enter, you see now that this one is moving the zeros, and I can redo it so you guys say like, oh no man, he's just BSing us. So command enter again, and you see that it's moving all the zeros to the left and the numbers to the right. And now I even added another one where, depending if you give it a direction, it can move them either to the left or to the right. So that's going to be your challenge from this after you're done. But I'm going to show you that it works. I'm going to do command enter. The first one moves the zeros to the left. The second one moves the zeros to the right. That's my time. I'm done.